All right, so we'll pick up where we left off. Here's an if statement. We'll comment that. All right, so we're going to set an integer a equal to 5 and check if a is greater than 4. And we already know this should go ahead and print a is equal to 4, and I'm sorry, 5, and then bump a. So now a will be 6, and it'll print out a is now 6. So let's test this. In other words, the if expression will be entered, and everything will work. If a were 3, then, for instance, this would say nothing, because we wouldn't get in here. So let's see. So a is 5, a is now 6. That worked. So let's just make sure that the opposite condition works. If this is false, it doesn't evaluate. So a is now 3. It never got in there. So let's set this back to 5 because I have some other things that depend on it down here. So let's get rid of that, and we'll come down to the next and break out there. All right, so here's an if-else. So at this point, a is 6. If-else, if a is greater than 4, well, it is, so this clause will be executed. We'll print out the value, which is going to be 6, and then bump it again. Otherwise, we're going to decrement a. And then we'll print out a is now whatever it is. So if a is 6 coming in, this is true, and it will print out a is 6, a is now 7. So that's at least my theory. Let's see what happens. A is 6, a is now 7. Good enough. All right, so what if a is 1 to start out with? Nothing should happen here, and here this is false, so a will be decremented, and it should print out a is now 0. So let's just make sure that our logic works. A is now 0. A is 1, a is now 0. All right, so let's set this back to 5, because that will keep everything good. Now, here's an if-else, if-else. I've set a to 0. So then we're saying if a is greater than 0, print a is greater than 0. Else, if a is less than 0, print a is less than 0. So what should happen? Well, no matter what the printf in the else clause is, this should happen because a is indeed equal to 0. So let's just make sure. Again, should be no surprises at all. A equal to 0. No magic here. It just came to the else because the if was rejected. The else if was rejected. So we fell through to the else. By the way, if this is 4 or any other number greater than 0, there should still be no surprises because a is greater than 0. Makes sense, right? So let's turn that back. Now here's a switch statement. By the way, you might be thinking, okay, big deal. You're controlling the value of a. Why would it ever be anything other than what you're controlling that value to be? Yes, you're right. In this case, that is absolutely true. Everything is contrived. It's silly. But very quickly, we're going to get into cases where there really is a point to making these kinds of decisions. We might be in a loop where the value of a, in this case, is constantly changing. We might get a input from the user in some way where we don't know beforehand what the value is. So we need to be able to make these decisions, and that's why. So now we have a switch. Now what we're going to do here is switch. We've set up an integer here called argcount, but we're going to switch on the value of argc. Remember argc? Well, I don't blame you if you don't, But if you look up at the top, remember that main gets an argument called argc, and that's an integer. And what that argument is the number of command line arguments to the program. So we're going to switch on argc. This is not contrived. We don't know how many things the user is going to type after they enter the name of the program. So we're going to find out. If there is nothing there, which by the way should never happen, because the name of the program itself is argument number 1. So there should always be a argument count, argc, of 1, at least 1. So just in case though, we're going to set arg count equal to 0 and break. Then, look what I did. I forgot to break on this one. If arg count is 1, we're going to print out there is 1 command line argument, and we're going to set arg count equal to 1. And I actually did something really goofy there. There is arg count command line argument, new line, and we're going to print that out and break. In the default case, there are 2, 3, 79 command line arguments. We have the default case, arg count equals argc, whatever that number is, and we're going to print out there are so many command line arguments, and print a new line, and then print out that number. So there we go. Let's get rid of the final multi-line comment, closure, and we'll save it, and we will run it. And it says there is 1 command line argument. Well, the command line argument is decision. It's the name of the program. So let's try something else. Decision 1, 2, 3. How many should there be? Yep, there should be 4. The name of the program, and then 1, 2, 3 command line arguments. So there are 4. So that we are exercising a little bit of control, or we're finding out something that we don't have any control over, i.e. the number of command line arguments. Now those command line arguments are strings, which remember I haven't talked about, but you can kind of get an idea as to what a string might be by looking at this. A string is actually a car star, a character collection. That star does not mean collection, don't get me wrong. That star means pointer. And in the next couple of discussions down the road, we will get to what a pointer is and why they are so important in C. Thank you very much.